One way to graph a line is to have 2 points. Another way to graph a line is to have the slope and 1 point. We saw last time how this can be done, and today we're going to take a look at how we can use an equation to find a point and the slope of a line in order to construct a graph. If we have an equation in the form y equals mx plus b, all of the information we need is right in front of us. The number in front of the x is the slope. That'll tell us the rise over the run so we can plot additional points. The b is the y-intercept. That's where the line crosses the y-axis. With these two pieces of information, we can easily graph any line we'd like to. In our first example, we want to graph the line y equals 3x plus 2. The first point we have is the 2. The 2 is the y-intercept. That's where the line crosses the y-axis. The 3 is the slope. We begin by plotting the 2 on the y-axis. That's our first point. Then we use the slope 3 over 1. We go up 3, right 1. Up 3, right 1. And then we can continue the pattern downward as well. Once we've plotted our points, we connect them with a nice line with arrows on both ends. Don't forget to write the equation of the line on the graph. Once we've constructed the graph successfully, we can then answer some questions about it. We can answer the questions, what is the slope? What is the y-intercept? Is the line a function? Is it one-to-one? Remember, to determine if it's a function, we simply use the vertical line test. To determine if it's one-to-one, we use the vertical and horizontal line tests. The domain and range of the graph can be used simply by looking at the picture. The graph goes left forever, and it goes right forever. Therefore, the domain is from negative infinity to positive infinity. The graph goes downward and upward forever, and therefore we say the range is also from negative infinity to positive infinity. In our second example, we're asked to graph the line y equals negative 2/3 x minus 6. The slope is the number in front of the x, and the y-intercept is the number at the end, negative 6. Please pause the video here and construct the graph using this information. Our slope in this case is negative 2/3. Our y-intercept is negative 6. We now have a point and the slope. I begin by plotting the point negative 6 on the y-axis. Then I use my slope negative 2/3. Down 2, right 3, down 2, right 3, and I can continue the pattern in the other direction. This line does represent a function. It's also one-to-one. The domain from negative infinity to positive infinity, remember domain is left to right. The range, negative infinity to positive infinity, the range is up and down. In our third example, we're given the line 3x plus 4y equals 16. In order to graph this line, we need to get it in y equals mx plus b form. We begin by subtracting 3x and then dividing both sides by 4. That gives us y equals negative 3/4 x plus 4. We now have a point on the y-axis, 4, and the slope, negative 3/4. We can now construct our graph. We plot the point at 4 on the y-axis, and we use our slope down 3, right 4, down 3, right 4, and we can continue the pattern in the other direction, and then we construct our line nice and straight with a ruler. It should fill the whole graph. Don't forget your arrows on each end of the line and to label the equation on the graph. Example 4 is for you to try. Once again, you'll need to get the line in y equals mx plus b form in order to construct the graph. Please pause the video here and complete example 4. I began this problem by adding 3x to both sides. That gave me y equals 3x minus 2. My slope is 3 over 1. My y-intercept is negative 2. I now have a point and a slope. I began by plotting the point -2 and then used the slope up 3, right 1, up 3, right 1 in order to construct the graph. I connect the points by using a ruler, and then I include my arrows at the ends, and I write the equation on the line. It is a function, it is 1 to 1, and the domain is from -infinity to +infinity, and the range is also -infinity to +infinity. The most challenging lines for folks to graph tend to be horizontal and vertical lines. Horizontal lines have the equation y equals. In other words, it crosses the y-axis at a certain point. Vertical lines have the equation x equals. It crosses through the x-axis at a certain point. In our fifth example, they ask us to graph the line y equals 7. That's like saying y equals 0x plus 7. It has 0 slope, and it passes through the y-axis at 7. I construct points and then connect them with my line. Notice the y equals 7 crosses through the y-axis up at 7. Then I label my equation onto the line, and I have completed my graph. The domain, because it goes left forever and right forever, is -infinity to +infinity. The range, the numbers that come out of this function, are simply 7. No matter what x value I plug in, the result is a 7. It is a function because it passes the vertical line test, but it does not pass the horizontal line test. This graph is not 1 to 1. In our final example, they ask us to construct the graph x equals 7. X equals 7 will pass through the x-axis at 7. Notice that this line has undefined slope. It's like the roller coaster running into a wall. The domain is simply 7. The only x value I can plug into the machine is 7. The range, however, is from -infinity to +infinity. It does go up infinitely and down infinitely. This is not a function because when I plug x equals 7 into the machine, it could give me any number in creation. So it's not a function, therefore it can't possibly be 1 to 1. This is everything you need to know about graphing lines using slope and y-intercept, as well as graphing horizontal and vertical lines.